Hello everyone, welcome back. This is Safa. In this video, we'll study the effect of zeros on the step response of a second-order system using MATLAB. We'll keep the poles fixed and only change the zeros so we can clearly see their impact. Okay, first here, CLC, clear the command window. Clear removes all variables from memory and close all. Close any open figure windows. This ensures we start with a clean environment. This defines the denominator of the transfer function. It corresponds to s squared plus 2s plus 1. All systems will share the same poles, meaning their denominator is identical. This allows us to isolate the effect of zeros only. Okay, here system without zero. This system has numerator equal 1 and denominator equal s squared plus 2s plus 1. So it has no finite zero. This will be our reference system. Okay, here 1 and 2 represents s plus 2, which means the zero is located at -2. We multiply by 1/2 to normalize the system so that G0 equal 1. This keep the final value equal to 1 for fair comparison. And here, system with 0 at -5, 1, 5 represents s plus 5, meaning the 0 is at -5. Again, we multiply by 1/5 to keep the DC gain equal to 1. And display transfer functions here. These are lines. Simply print the transfer function in the command window so we can verify them. And here, this plots all three step responses on the same graph for comparison. And here, these lines improve readability by adding grade, legend, title, and access label. You can see. Okay, run. Here we can see command window, system without zero. Okay, and here. All three responses start from 0 and settle as 1. This is because we normalize the DC gain. Okay, blue curve is no zero. Okay, smoothest response, slowest initial rise, no aggressive behavior. Okay, yellow 0 at -5. We can see here. Okay, faster initial slope, slightly more aggressive than no zero system. And here 0 at -2. Fastest rise time, strongest effect on early response reaches a steady state first. Zeros mainly affect the transient shape of the response. A zero closer to the imaginary axis has a stronger influence on system behavior. Zeros increases the initial slope and can increase overshoot in other configurations. Okay, that's it. Thanks for watching.